Hey, welcome to this tutorial, Introduction to Machine Learning in Python with scikit-learn. My name is Fred Fan. I'm assistant professor at the University of Michigan, Dearborn. Let's get started. For this tutorial, we'll be using a Jupyter Notebook. If you want to run this Jupyter Notebook on your local machine, you can go to my GitHub page. I have the URL down here. Just go to this page, and then if you're not familiar with GitHub, you can just go click this code button and then click download the zip. It will just download the zip file which included this notebook. And if you do not want to run the notebook locally, we're going to be using the Google Colab, which is a cloud-based tool for running Jupyter Notebook. So if you want to follow along, we can do a Google search for the Google Colab. So first you will need to log into your Google account, because in order to use the Colab, you will need to log into the Google account first. And then I'll just search Google Colab. And it's a first link here. And once you see this, for one of the tab, it's called a GitHub. So I'll just click this GitHub tab. And then I'll zoom out just a little bit. So here for the search, you will need to search my GitHub username, which is frfeng, and then frfeng. And then once you typed in my username, just click the search button. And then for the repository, you will need to find the one that says scikit-learn tutorial. And now we can see we already have a Jupyter Notebook here. So once you see this, just go ahead and click it. And this would open the Jupyter Notebook in Google Colab. Okay, so you should, once you click that notebook, you should see the notebook, something similar to on the screen right now. And the first thing that you'll need to do is to, if you haven't done this before, you will need to upgrade your the scikit-learn library to the latest version. So the Google Colab was actually not using the latest version as of now. So all you need to do is to uncomment this last line here, and then click this play button to run this shell. So this would just upgrade the scikit-learn to the latest version. Okay, because we're going to be using some of the features that were not available in the version that Google Colab was originally using. Okay, so now we've done with that. Okay, so we're good to go. So about this tutorial, it's for Introduction to Machine Learning in Python with scikit-learn. So I have my email address here. So if you have questions, feel free to drop me an email. So for the prerequisite for this tutorial, so we're going to be assuming you already have some familiarity with Python in general and its common libraries, specifically the NumPy and the pandas. And if you're not familiar with Python, I actually recorded a Introduction to Data Analysis in Python workshop about half a year ago. It's uploaded on YouTube. It's a 4.5-hour workshop. So if you just want to know some basics in Python, I would encourage you to follow this workshop if you have half a day to spare. So for this YouTube video, it's actually, I included a timestamp for some particular topics. If you're just want to know some particular topics, you can just go directly to the timestamp here. Okay, so you can find this YouTube video by directly clicking this link here. So that's the first prerequisite about the familiarity with Python. The second, it's we assume you have some basic understanding of the regression and the classification models, because we're going to be using some of those for demonstration purposes. And that's it. In terms of the goal of this tutorial, is to give you a taste and some hands-on experience of how we can do machine learning in Python using the scikit-learn library. For the scikit-learn library, I actually included the link to its official website. It's a very popular machine learning library in Python, which can be used for, it incorporates a lot of the very common machine learning algorithm. For example, as you can see here, classification, regression, clustering, dimensionality reduction, or preprocessing, a lot of very common machine learning methods in this library. So that's what we're going to be talking about in this tutorial. So the scikit-learn library is open source and free. So there's no barriers of entry. Everyone can use it. And also there's a very large open source community. If you have any questions, if you just Google it, and you would likely to find the answer for that. And again, like I mentioned, it implemented a large number of common machine learning methods or algorithms. And one of the unique things about the scikit-learn is it has a very clean, uniform, and streamlined API, which I'm going to talk in more detail later in this video. And then it is widely used across industry and academia. So actually on their official website, they listed some of the companies that are using scikit-learn, for example, JP Morgan, Spotify, and as you can see, there are a lot of others as well. So it's a really popular machine learning library. So we talk about what scikit-learn is for. And the next thing I want to briefly talk about is what scikit-learn is not for. So if you want to do some in-depth statistical analysis or hypothesis testing, the scikit-learn is probably not the best tool for that. And for those kind of the statistical analysis, there's another library called stats models, which is very popular Python library if that is statistical analysis is what you are trying to do. So that's that. And also, if you want to do some deep learning or reinforcement learning, there's some other libraries like a PyTorch or TensorFlow that are specialized for that. So that's not for scikit-learn. So now let's get started. So for this tutorial, feel free to just watch the video and to see how I'm gonna do this kind of coding. But I would encourage you to actually open this notebook either on your local machine as a Jupyter notebook or just on the Google Colab, so you can follow along. You can execute the code and play with the code by yourself. First we'll just import some common libraries we'll be using later. So in in the Google Colab, if you want to run a cell of code, you just play this. Click this play button to run the cell. And then for the first part, we're gonna read in some data for this demonstration. So for this tutorial, we'll be using a data set for the bank customer data for a marketing campaign. So the way we're gonna read in this data is to use pandas. So we have this URL here, and then we're gonna just read in this CSV file as a pandas data frame, and then we're gonna just show the first few rows of this data frame. So we'll just click this play button. Actually, let me make the look a little bit bigger. I think this is good. As you can see here, now we already read in the data. So each row is representing one customer, and each column representing some information about that customer. For example, their age, their job, their marital status, education, and some other information as well for each of the customer. And so this is to run just some common pandas command to run the first, to give us the first 5 rows of this table. And also we can do the dot tails to give us the last 5 rows of the table. So we have about 4,500 records. So these are the last 5 rows. And also we can do run the dot shape to give us the number of rows and columns of our data frame. And also, by the way, we just give this data frame, this data table a name. We call it df. So that's why it starts with the name of the data frame, and then dot, and then apply a method. So, and also it's typically good practice to check the data types by calling this dot d types, so that we will know what is the data type for each of the column. For example, age is integer number, and the job So object here just represent it's a string. For example, job, it's a text or string. So that is called a object. And also there are some other things like floating numbers as well. So these are the three common data types. And also the next cell is basically to check whether there are any missing values or null values in the data frame. So we're just gonna click this run button to see. And then here, essentially if we don't do the sum, let me just delete that for now. If we just do the isNull method, if I run this cell, it will just, for each of the value in the data frame, it will just return true or false to indicate whether that's a null value or not. And then we can do the dot sum just to give us a summary of how many null values are there for each of the column. As we can see here, majority of them doesn't really have null values, but for some of the columns, we do have some null values. So that's something we're going to be deal with later in the pre-processing. So that's that. And for this machine learning problem, our goal is to develop a model that predicts whether a customer will subscribe the service or not. So I mentioned earlier for this data is for each of the customer, it gives us some information. And if we scroll all the way to the last column of this data frame, it's called a subscribed. So this is a very important column. So this is to indicate whether this customer subscribe to their service or not after the marketing campaign. So 0 means the customer did not subscribe, and if it's 1, it means that customer did subscribe after the marketing campaign. So this is about 4,000 data points that we have. So our goal is to train a machine learning model that kind of learn what is the pattern, what information going to lead to the customer subscribing to the service, and then we can have a predictive model that predict whether a new customer will subscribe or not. So this is essentially a binary classification problem. So for this column, subscribed, if we want to know for our data set how many of those customers actually subscribed, we can do a value, we can apply this value counts method. So this would just give us the value counts. So we have 4,000 customers who did not end up subscribing the service, and we have about just over 500 customers did subscribe. So this is from our data. As you can see here, this data is unbalanced data. So majority of the people actually did not subscribe after the campaign. Another way that you can, so this is value counts would give us the counts of how many customers subscribe or not subscribe or subscribe. If you want to know the percentage, one of the arguments we can pass to this method is called normalize equals to true. And now if I run this, it will just give us the same information but in percentage. So for example, here we can see about 11% of the customer ended up subscribing. The majority of them did not subscribe. Okay, so this is just give us some general idea about this data set. And another thing is we can also use this group by method to see what are the typical values for the customers who are who subscribed versus not subscribed. So we're grouping the data based on whether they subscribed or not. So we can do this group by. So by this column subscribe, and then for all the customer within this group, either subscribed or not subscribed, we're gonna calculate the mean for all the informations from other columns. So if I run this, as you can see here, so we have 2 rows. So for those customers who did not subscribe, we can check the mean value for some other information, their average age or average credit the bank balance or some other informations. Versus for the customer who did subscribe, as you can see here, one of the things, it seems the customer who did subscribe has a much higher value for this column called the duration. So this might be a useful information in terms of predicting whether a customer will subscribe or not. So that's just some exploratory data analysis we can do. There are certain other things we can do, but for the time of the tutorial, I'm gonna just do this simple one. So now let's move to the second part. Let's talk about how we can build a machine learning model that predict whether a customer will subscribe or not. So for the part 2, we're gonna build a logistic regression model with just a few of those numerical features. So for simplicity, for this part, we're only gonna choose this 3 column as the predictor of our model. So all these 3 predictors are numerical values. And then later in the part 3, we're gonna include some categorical predictors as well. But for this part, we're only gonna use these three features or predictors for this logistic regression model. So in the scikit-learn, the way that we can build a machine learning model is actually have a very standard procedure. It applies to all the models that it doesn't really matter it's a logistic regression or some other models. The procedures are pretty much the same. So in the step 1, we need to specify what features to include in the model. And the way we can specify that is constructing something called a feature matrix. You can just consider the feature matrix as a table where each of the column is one feature. Okay, and each of the row is just one observation, and in this case, one customer. And here we can just, and typically we use a capital X to denote a feature matrix. This is just by convention. Typically in machine learning, we use a capital letter to indicate it's a table with multiple, it's a 2-dimension table with multiple columns. So that's why we're using the capital X here. So we only include these 3 columns. And if we want to take a look at it, so again, the dot head is just show the five first rows in our feature matrix. So now we have these 3 feature matrix. Okay. And also I want to briefly mention that for this machine learning problem, I chose this 3 feature just because they're kind of simple. They're not the best predictors for this particular data set, but I'm choosing those 3 just because their simplicity. Okay. So now we have our feature matrix that is saved in this capital X here with 3 features. That's step 1. And the second step is to specify the target. And in this problem, it's just whether the customer subscribed or not. Okay. So the target in machine learning is just the output of the model. And if we are working on the supervised learning problem, like in this case, the classification, if we want to train a model, we also need to specify what is the label for the customer, in this case, the target, which indicate whether the customer subscribe or not. And in this particular case, we're interested in whether the customer subscribe or not. So that is just saved at one of the column called the subscribed that we saw earlier. And here, for the target, typically people use a lowercase y to indicate it's a target. So again, it's just by convention. If we run this cell, it would just show as you can see here, it's a single column. 0 means that customer is not subscribed. If we see a 1, that means that customer is subscribed. And the first column here is actually, it's not the value, it's just the index. As you can see here, starting from 0, it's just index. The actual value of y, it's the second column here. Okay, so this is how we can specify the target. As you can see here, the majority of them are 0. So we only have about 11% of them are actually 1. But if you want to double check, we can always, let me uncomment this line here. And also, by the way, in the notebook, if you want uncomment, the keyboard shortcut is a Control/. You can do that to toggle through the common, uncommon. So here I can just do the sum of the y. So that would give us the number of 1s that we have. So we would have 521 of those, which are the customers who actually ended up subscribing. So in step 2, we specify the target y here. And in this step 3 is we're going to split the data into a training set and a test set. So this is one of the golden rules in machine learning. It's models should never be tested on the same data they were trained on. So you should always separate those two. Okay. So in step 3, we're actually going to split our data frame into 2 parts. One is called a train set. We're going to use the train set to train our model. And once we have the model, we're going to test or evaluate the model performance on a different data set, which is called a test set. Okay, and in scikit-learn, it makes very easy for us to split our data into these 2 parts. So all we need to do is to use this function called a train test split. And before we use this function, we first need to import it, just like a lot of other Python functions, because this function is actually within the scikit-learn library, and it's within a module called a model selection. Okay, so this is how you can import a function from the library. So here, the way that this function works is we first just call this function, and this function takes some arguments. The first is, as you can see here, the capital X, and that is our feature matrix. And the second is Y, which is our target. And then we can specify how much of the data I want to use when splitting. For example, if we want 20% of the data to be the test set, we can pass the 0.2 or 20% to the test size. And by default, they're going to use 25% if we don't specify this argument. But if you want 20%, this is how you can specify that. And by default, it will use a random split because it's using it will split the data randomly. But for reproducibility, oftentimes you should also set a random state to an arbitrary number, so that if other people are gonna run your code to reproduce your result, if they use the same random state, they're gonna have the exact same split as when you were executing this code. Okay, so that's that. Another thing we can do is to typically, if your data for classification, if your data is unbalanced, or if you have a rather small data set, we should also use the stratification for your data so that the labels are roughly in the same proportion as your original data. Okay, so, and then the output of this function is essentially just 4 parts. So for the feature matrix, xtrain, that's the feature matrix for the train set, and xtest, that's a feature matrix for the test set. And then the ytrain is a target for the train set, and the ytest is a target for the test set. For example, here if we run it, and then we want to see the first 5 rows of the test set. As you can see here, we have, so these are the 5 rows that included in the of the feature matrix in the test set. Okay, and we can also see the first 5 rows from the target in the test set. As you can see, the index, essentially it's a random split. So that's that. And in step 4 is we need to instantiate our logistic regression model or classifier. So the way to do that is we just import this function called the logistic regression. So that's from the scikit-learn library, from a module called the linear model. And then here it's just a way that we can instantiate or make an instance of this logistic regression model. And then we save this instance or object, give it a name. So we typically use a CLF to stand for a classifier, but you can name it differently if you want. So once we have an instance of the logistic regression model in step 5 is to train the model by applying the fit method based on the training set. Okay, so this line of code essentially would just, so first we type in the name of our model, which in this case, it's a logistic regression model, and then we apply this method .fit. And then here, the key is we're only gonna use the data in the train set, okay? So here, first we specify the feature matrix for the training set, and then second is a target for the train set. And now, once we run this line of code, we're gonna actually have the model fitted to based on the training set. Okay, so here give me an error message because I forgot to run the previous cell, so we needed to indeed run this cell. So now we have the CLF object. Now we can run this. So now we have a logistic regression model already been fitted into our based on our train set. And if you want to know the coefficients of the logistic regression model, you can just print out those information. So these are saved in some of the attributes from this of this object. So you can see these informations as well. So that's that. And now once we have the model fitted based on the train set, if we want to evaluate the model performance, we should only use the test set, which was not used as part of the training. Okay, so here, for example, for the feature matrix in the training set, in the test set, we can use that for making prediction. And the way in scikit-learn, if you want to make a prediction, the method is called just called a predict. So first we again call our classifier and then dot predict, and then for the argument we just pass the feature matrix of the test set. Okay, and then we save the predicted value into a variable called ypred. Now once we have that, lastly, the way we can evaluate the model performance is we can compare our model predictions based on this training set with the actual target of from the test set. Okay, so here we're just using a NumPy function called column stack to stack those two columns next to each other. For example, for the first customer in the test set, the true label or the target is not subscribe, and our model says they're not going to subscribe. So that's correct. And second one, the true label or the target is subscribe, and our model prediction is also subscribe. So that's correct. So we can essentially compare these two and to see how well our classifier performs. Okay, and so here we can do some standard common ways to evaluate the performance of the classifier. For example, we can plot the confusion matrix for that. So there's also a function just called confusion matrix. In scikit-learn, we can easily do that. So it would just give us a 2x2 table in this case. If you want your confusion matrix to look a little bit nicer, so here we can convert that into a pandas data frame to add the column names and the index names. So now we would have this information. This table, confusion matrix in the pandas data frame. For example, there are 791 customers who are truly not going to subscribe, and our model says they're not going to subscribe. So that's correct. And there are 15 of those, actually, they are subscribed, and our model successfully predicted so. And here are just the type 1 and type 2 errors in our classification. And also we can check the accuracy score. The overall accuracy of our classifier is about 89%. Actually, if our sample size, our data size is unbalanced, the overall accuracy is actually a pretty horrible metric, just because if about 88% of my data are not to subscribe, I can just have a very silly model just to see everyone not going to subscribe, and I will already have an accuracy of 88%, right? So 89% is not really very impressive. Typically, for this kind of unbalanced data, we should look at some other metrics, for example, the recall or precision or F1 score, some of the more advanced metrics. So if you want to see those metrics, there's a function called the classification report. If you run this, it will give us some other information in addition to the overall accuracy. For example, for this, our classifier, we would have a recall of 14%, and the precision is 60%. Okay, so that's how you can evaluate a classification model, and we can also use something called ROC curve. And here there's also, in scikit-learn, there's a function just to generate the ROC curve. So these are a lot of code, but most of these are just for decorations. The most important line of code would be, let me see where it is, so this line, which is to call this function ROC curve from the scikit-learn, and then it will just gonna generate the false positive and the true positive, which would be used for plotting this ROC curve. Okay, so that's that. And we can also do the cross-validation for our models. Essentially, the idea is we're gonna split the training set into multiple, roughly even folds. And then for each of the iteration, we're gonna use one fold for testing purpose and the rest of the fold for training the model. And then we're gonna do it for different iterations. And for each of the iteration, we would come up with a performance metric, for example, the accuracy or the recall. And then lastly, we just average that metric over all the iterations, okay? And here in the scikit-learn, we can actually do that rather easily. So there's a function called the k-folds. And for this k-folds function, we can, for example, I can just run this to show you. So this is by default. If we set the 5-fold cross-validation, essentially these are the indices that are used. For example, in the first iteration, we're using the first 3 customer as the test set and the remaining for the training the model. And then the next iteration, we're using the next 3 customer for testing and the remaining ones for building the model. And then we can do that 5 times. And typically, you should shuffle your data rather than just not shuffling, just because your original data may already be sorted in some way. So it's good practice to shuffle your data. For example, if we set the shuffle to true, now you can see here for each of the iteration, it's shuffled. And also for the research reproducibility, it's good practice to set a random seed so that if other people can reproduce your work, you would get the same way of splitting your data. And then once we have that, then and also one more, the next cell is, again, if you have small data set or highly unbalanced data, it's better to stratify use a stratification when you're splitting. So there's a function called stratified k-fold. So you can do that as well. And once you have that, then for the cross-validation, there's actually a function that do most of the things for us. It's called a cross-val score. So it's just one line of code. Essentially for this cross-validation, it's what we need to specify is the model here is our logistic regression model. And then here, our feature matrix is X. So notice here, we're not using the X train, but just use X because this function would just split the data for us. So when we just need to pass the entire the feature matrix for our entire data to this function. And same for the target Y. And CV is essentially the cross-validation, and that is based on our result from the above cell. And you can specify what is the metric you care about. For example, I can one of the common ones in binary classification is called for the ROC curve, it's called area under the curve. So we can use that for our cross-validation. And then we would, because we set it to 5-fold cross-validation, it will just give us 5 numbers. If you just want to average them to average those 5 numbers, you can just apply the dot mean. That will just give you a single number. You can do you can also check other metrics. For example, you can do the overall, you can do the accuracy, or you can do the recall as your scoring metric. So that's how you can do the cross-validation here. So here for the cross-validation argument, we set it to be the same as before, but and here in this cross-validation function, k-fold function, you can specify a lot of the detailed settings, for example, the random state and some among other things for the cross-validation. But if you don't care about any of those, another way is you can also just give it an integer number. For example, if I just want to have a 10-fold cross-validation, I can just set the CV equals to 10. And then if I run this, or should it run as well? And then if I actually delete the last part, it will just give me 10 numbers for the recall. So that's that. And then once we have the model, we can use our model to make predictions for some new data or out of sample data. So here I just created 2 new data points for Tom and Jerry, and we have some information. And then we can make predictions by, again, call this method called .predict. And then here for the argument, we just pass our new data to this method. And then they would just give us prediction for these two new data. For example, it says, based on our model, it says Tom is going to subscribe and Jerry is not going to subscribe based on this information. Okay, so that's that. Now let's move to part 3, the feature processing. So for this part, we're actually going to use some other features just for demonstration purposes. So for this part, we are choosing these 5 features. And then for this marital column, or this feature, is actually categorical. So it has 3 values. It could be either married, single, or divorced. Okay. And here, similarly, we can split our data. One of the preprocessing I want to talk about is the imputation of missing values. So if you're working with real world data, chances are your data is not going to be complete. There are going to be missing values. So here, typically, if you just throw or discard the row, if it contains any missing values, you may end up having to throw out a lot of rows. So oftentimes, those may not be the best way to do it, because some of those rows, even though they may miss a single value, but it may still be valuable. So a better strategy is to impute the missing values. And there are different strategies, specific strategies of what values you can use to replace the missing value. So for numerical missing values, typically we can replace the missing value with a mean of the entire column, and that is by default in scikit-learn. Or we can replace that with a median of all the other values in this column. Okay. So here, for example, let's check the missing value one more time. So we have, for some of the columns in this feature matrix, it does have one missing value for the day and the campaign. So for example, for the day and campaign, if we take a look at the first 5 rows, so NAM means it's a missing value. It stands for not a number. So if we actually calculate the mean for these 2 columns, for example, for the column day, the mean is 15.9, and for the campaign is 2.79. Okay, so basically the way we can impute this missing value is to use the mean value to replace that. So here's how we can do it. So we can import a function called a simple imputer. And for this simple imputer, we can just do something called, use a method called a fit transform. And then we just specify these 2 columns that we want to do the imputation. And let's run this. Now you can see those missing values are not replaced by the mean value of that column. Okay. So that's what we can do by using a simple imputer. And for categorical missing values, obviously we cannot calculate the mean if it's categorical, but what we can do is to typically we impute that with the most frequent categories of that column. For example, for the marital column, we have one missing value here. And if we do the value count, we know that the majority of the customers are married. So that's, if we are going to impute value, we can use the married to replace this missing value here. And then that's what we did in the next cell. It's essentially the strategy is the most frequent. And if we do that, as you can see here, now this missing value is replaced with the most frequent category, which is married. Okay, so that's that. And the next part I want to talk about is one of the processing. If you want to incorporate categorical features into your machine learning model, we need to encode that into to numerical values. And one typical way to do that is called one-hot encoding. So this is how you can do it. It's essentially we are creating dummy binary variables for the categorical variables. So we can just call this function called one-hot encoder, and then we can do the fit transform. So that will transform this categorical feature into a dummy variable, as you can see here, because this marital status would have three different values, three different possible categories. So now we have three columns, either 0 or 1, indicating whether that customer is divorced, married, or single. Okay, so if you want to check the category of these three columns, we can do that as well. So the first column indicates whether that customer is divorced or not. Second column is married or not, and single is 0 or not. Okay, so it's called one-hot encoding because you can only be one So for these three columns, for each of the row, there should be only one of the value is 1 and all others are 0. So this 1 is called hot. So that's why it's called one-hot encoding. So that's that. And another type of preprocessing is to scale the values. For example, your original features may be in very different scales, and we can scale those features. There are multiple ways you can do that. So one way is to use a standard scaling, which scale the feature to a 0 mean and unit variance, or we can do the min-max scaling, which scale the values to a given range, for example, from 0 to 1. And for example, let's take a look at this duration column. It has these values, so we can do, for example, here the next line is to do this standard scaling, so standardization by first fit, and then calling this fit method, and then for this column duration, and then we transform that. Okay, and typically if we need to apply a fit and then transform, actually oftentimes there's a shortcut function for that, method for that. It's called fit_transform. So we can also run the next cell that would give us the exact same result, which is to standardize this duration column. And we can certainly do another kind of transformation by using the min-max scaler as well. So lastly, we can also define custom functions for the transformation. For example, if we want to do a logarithm transformation, we can certainly do that by calling a function called a function transformer. And here we can just have our custom function, and then we can do this logarithm transformation for this column as well. So these are the pre-processing. Lastly, I want to briefly talk about one of the powerful things about scikit-learn in machine learning is to build machine learning pipelines. So pipeline essentially it chain multiple steps together. So for example, start with data preparation, and then building our model using the training data set, and then evaluate our model, and then lastly deploy the model. So this can be a machine learning pipeline. So here I talk about the reason that we should build pipelines. It's simplify and automate the workflow of machine learning, and it make it harder to make mistakes if everything's encapsulated into one pipeline. And people even say that if you're not using a pipeline, you're probably doing it wrong. So here, I'm running short on time, but here I'm gonna skip some of these. So we can essentially use a pipeline to do pre-processings for different features or set of features. And here we are basically build using a function called column transformer that we can have different processings for different features. For example, we can, let's see. So here we can have a processing that first do the simple imputer, and then after imputation, we would do the one-hot encoding for some features, And for some other features, we can do the simple imputing, and then we can standardize that feature. And for some other, and then we can put everything together by using a pipeline. So I have the code here. And then I'm gonna just run this code as well. So this is to show that you can also, if you have a lot of different features, you don't have to name them one by one, but you can use this function called the make column selector to specify what column to select. And then we can take a look at our training set. And then we can just apply everything together by applying this preprocessor, which is a pipeline for our training data. And then we can just pass that. And then we can just build a pipeline by using this make pipeline function. And then we can just chain this preprocessor with our actual classification model. And then we call it pipe. And for this pipe, we can just again use this fit function to train this pipeline, which include the preprocessing and our classification model. And then we can also kind of visualize our pipeline that we had here. So here we have our visualization of our pipeline here. So we have different procedures for different sets of features. And then lastly, we have a classification model. And then let's see. So here is just some more detailed code about how we can make predictions using our pipeline here. So lastly, I want to talk about one nice thing about scikit-learn is make it very easy to try different models, because everything is have a uniform and streamlined API. For example, so far we talk about we have a classification model of the logistic regression. But if we want to try a different classification model, for example, the k-nearest neighbor, the only code that we need to change is in this cell. We just call a different function. In this case, k-neighbors classifier. And then everything else are the same. So we can build a machine learning pipeline by calling this make pipeline function. So this preprocessor is exactly the same as we used before. And then the only change here is for this classification model is now a KNN model. Okay, so we can visualize that. So it's the exact same pipeline, except now the classifier is our KNN classifier. And then we can train our pipeline using the training data, and we can do the cross-validation. And lastly, one very useful function is in scikit-learn is called grid search cross-validation. So it's called a grid search CV. So this function is extremely useful because we can do a grid search of all the hyperparameters in your model along with the parameters in your preprocessing. So here, if I run for our pipeline, if we do the get parameters, it will give us all the available parameters that we can set for the grid search cross-validation. So here, I just, for example, in this case, we just want to specify some of the parameters we want to do a grid search. For example, for our preprocessing, for the standardization, we can actually try 3 different ways. One is for the standardization, we can use the standard scalar, or we can do a min-max scalar, or we can do a pass-through, meaning that we don't do any processing, we don't do any scaling for this. So we can try these 3 options. And similarly, for the imputation, we can also try the mean, strategy equals to mean, or strategy equals to median. And for our k-nearest neighbor, we can set the number of neighbors to be 3, 5, or 7. Or for the, so these are the hyperparameters we can do the grid search for the KNN model. For example, the distance is whether Euclidean or Manhattan distance, or whether you want to do the weight or not the weight. So you can set all these things that you want to do a grid search. And lastly, all you need to do is to run this grid search CV function, and it will just do the grid search of all the combinations that we just described here. Okay, usually it takes a few seconds to run because essentially you're running a lot of models. So essentially this line that we just had, so this is already give us a result. So this is the best configuration of the model. And in this example, we actually tried 3 options for the standardization, 2 options for the imputation, and this, among other options. So essentially, we tried 72 different model configurations. And for each of the configuration, we did a 5-fold cross-validation. So this single cell actually ran 360 models to fit to the data. So that's pretty impressive. So imagine if you have to do this manually, so you're gonna take a while, but scikit-learn make it really easy to do that. So lastly, it's just a summary of the scikit-learn uniform API, make it very easy for people to do common machine learning tasks. So if you want to fit the model, it doesn't really matter what kind of model it is. The API, it's always the same. So it's called this fit method. If it's a supervised learning, we specify the feature matrix and the target. If it's unsupervised learning, like clustering, you don't specify the target. And then we have the transform method, and we have the predict method. So these are the same method for all the machine learning models that you can try. So that's all I have. And lastly, I included some resources here from these links. So if you want to know more, I would encourage you to check those links, official examples, tutorials, and the user guides for scikit-learn. So that's the end for this tutorial. I hope you find this helpful, and I'll see you guys next time.